name is Erika. I am a STEM tutor, and today I'm going to be taking a look at this classic area problem. This problem demonstrates how you can use quadratic equations to solve these classic area scenarios like what is given here in this problem. So we are told that we have a picture frame, and this particular frame has a length which is 3 centimeters more than its width, and that the area enclosed by the outside of the picture frame is 154 square centimeters. And we are tasked to find the width of the outside of the picture frame. So we see in this problem there's two key equations we want to remember when we're solving this. And the first is going to be our area definition, which is that the area is equal to the length times the width, and our quadratic formula, which is given here. And so we're going to be using that quadratic formula in just a bit. But my favorite thing to do with these kinds of problems is to first sketch out a picture. So I have here a basic sketch of our picture frame, and we want to label our length and our width. But in our problem, we're not told a quantity for a length or width. We're only told that this frame has a length which is 3 centimeters more than its width. So for this kind of problem, we're going to represent our width with the variable x. And since our length is 3 centimeters more than the width, we can represent our length with x plus 3. So I'm going to go ahead and go to board number 2. And now that we had our picture defined with a length and our width, keeping that in mind, we can go ahead and attempt to solve this problem here. So remembering that area equals length times width, and we have our length defined as x plus 3, our width defined as x, and we remember that we're told the area is equal to 154 square centimeters. So we can go ahead and plug each of these into our area equation. Area for 154, length is x plus 3, and width is x. And we can go ahead and multiply this all out. Now remember the distributive property here. We're going to distribute this x to both of these. So it's going to be multiplied by that 3 and multiplied by this x. So when we distribute that all out, we get 154 is equal to x squared plus 3x. Now we see here this is a quadratic equation because it has a power of 2. And so we want to go ahead and use our quadratic formula to solve for x. But in order to do that, first we need this to be in standard form. And this is what the standard form is. Look what it looks like over here. The standard form of a quadratic equation is 0 equals ax squared plus bx plus c. And currently our quadratic equation is not in that form. So we want to get it into that form before we can use the quadratic formula. And so to do that, I'm going to go ahead and subtract 154 from both sides to move that term over here. And so when we do that, we get a 0 equals x squared plus 3x minus 154. This is in standard form. So now we can go ahead and proceed with the quadratic formula. But first we identify our a, b, and c. So looking at the standard form, we can see that our a equals 1, our b equals 3, and our c is equal to negative 154. So now with that in mind, we can go ahead and continue to solve with the quadratic formula, knowing that a equals 1, b equals 3, and c equals negative 154. So all we do now is we just plug each of those values into our quadratic formula, just being mindful of the signs. So make sure, like with the c equals negative 154, you carry that sign over when you plug it into the quadratic formula for c. So you can see here I plugged each of these values in, and we're just going to go ahead and multiply those all out. And when you do that, you're left with this here, negative 3, and be mindful also of this plus minus sign here. When I simplify all that out, I'm left with this. And so we are going to only take here, so the quadratic formula will give you 2 values for x, and you're going to only want to take one, and that's going to be the positive value, because this will read negative 3 plus 25 or negative 3 minus 25, and minus 25 will give you a negative value for x, and a negative width does not make sense, so you only take the positive. So I'm going to continue to simplify this all out, and when I do, I'm left with x equals 11, and so that is our width value. And if we plug that back into our original picture, we will find that the width equals 11 and length equals 14 centimeters. And when we plug those all into our area formula, we get area equals 154 centimeters squared, which was our original area given here. And that's all. I hope so much I was able to help, and have a wonderful day.